So now I will talk about that how pseudopotential will be generated, right? So in the last section or the last lecture, I told you that how atom program will be installed. So now let us open the terminal. So open the terminal. There is no need to use conda environment, so let us deactivate that. So I have installed Siesta in NMM folder, so I go inside it, and then inside it there is a sudo, and inside sudo there is a atom code, right? Means I go inside the atom code, and inside the atom code there is a directory named tutorials. So you go inside the tutorial, and inside it there are 3 directories: all electron, PS generation, utils, right? So you go inside the, let us now understand these. I am not talking about the all electron, but first of all let us go inside the PS generation. It contains some examples for argon, barium, carbon, copper, iron, sodium, oxygen, and so on, silicon. Also, if I go inside the utils, then utils contain 3 scripts. One is the AESH, right? One is AESH, and another is PG.sh, and the third one is the PT.sh. So, pardon? Okay, I will do that. So AE means all electron. If you want to do all electron pseudopotential, means all electron calculation if you want to do. Another is the PG.sh, means pseudopotential generation, and third one is PT.sh, pseudopotential testing. I will tell you simply PG.sh pseudopotential generation with core correction and without core correction, right? With core correction and without core correction, because what we are doing in the pseudopotential approach, we will use the valence electrons and we will not consider the core electrons. But in some cases, core electrons will play a very important role, a significant role. So that means we have to incorporate few of the core electrons. So there are 2 possibilities. Either you will include those manually, or by default you can include core correction. So I will tell you how by default core correction can be made. It was written in the manual of atom code also. I learned from that, right? Okay. So, and I will use this script pg.sh, right? So I am just coming back, means coming outside it, and then go inside the PS generation. First of all, I will take the example of silicon. There are several files: silicon.test.inp, silicon.tm2.inp. So what I will do, there are different flavors for pseudopotential generation. One is the HSC and another is the TM2. TM2 is a better choice. So I will use Trollier-Martin advanced scheme, so TM2 I will use that. So I'm just coming outside, and I'm not disturbing the actual directory structure of the files which are already given to me. So what should I do? I will make a directory, you can call it anything. So si underscore test underscore test ls, say this is the test directory which I have created. And another thing, when you create some file or directory, never give a space. Never give a space. In place of space, if you write down underscore, that will be better. Rather than if you write down silicon dash means space and then test, then sometimes it will read it, means on command line it will read two files like this way. Okay, so this is so I am going inside the silicon underscore test, the directory which I have created. Now it contains nothing, so I copied input file from the directory which I have already from the directory which is already given, right? So I copy it, I come outside it, so it is si, it is the directory. I go inside it and it contains these three files. So I copied this input file si.tm2.inp and I pasted in the same directory. So I write down /, and I want to rename it. So to rename it, I write down it as si.inp. That's what I did here. Means I copied this file from silicon directory and pasted into the directory in which I am sitting, and I want to paste it with the different name. So // means the directory with which I am sitting, and si.inp means it is the new name of the file which I already copied, right? So यहाँ पे ये फाइल आ जाएगी. See, si.inp file will be there. Let us try to understand this file now. ls, it is si.inp. Let me open. You can open it in the gedit also. si.inp. So every column has its importance. Once something is shifted from one column to the another column, then that creates a problem for me. Then that creates a problem for me. So PG means pseudo-potential generation. It is the name of the system. TM2 means Trollier-Martin advanced scheme. This is basically 3.0. It is the cutoff radii for the logarithmic derivative. I will talk about it later on. 3.0. Then what is it? These are the default parameters, need not to write down. And this is the exchange correlation flavor which I am using. CA means separately elder, R means relativistic. R means relativistic, right? It is a relativistic. If in place of R you write down S, then it is a separately elder with spin flavor. With spin, it means including spin. But if you do relativistic calculation, means, or if you put relativistic parameter, then it automatically incorporates spin. And in any code, especially in Siesta, when you want to include spin orbit coupling, then your pseudo potential should be relativistic. So better you prepare relativistic pseudopotential. And let me now understand different parameters. So what is this? Let us understand this. This is 3 and this is 4. Let me try to look at the electronic configuration of this what we call silicon. Its electronic configuration is 1s2, 2s2, 2p2, 3s2, 3p2. So these are core states. These are the core states, and what is it? These are the valence states. Means valence electrons are sitting here. But when you will run siesta, it will require 4 orbitals, not 2 orbitals, because electrons are sitting in the 3s and the 3p, but it requires higher orbitals also. So that means, what does it mean? This represents core and this represents valence. Valence is always 4 when you will run siesta. Valence is always 4, not 2 or 3. But if electron is not sitting in the other orbitals, then make them 0. And follow the order. So that means it is the 3, means it is principal quantum number and it is the value of L. So it is 3s2. This is default value, make it 0 for everywhere. Then 3p2 means it was written also in here. And this hash, it is basically a comment. There is no need to do this. Then 3d0, 4f0. So that means all the 4 orbitals are mentioned. Right, so this is the input, and what is it? It is the cutoff radii. I will talk about the cutoff radii later on when we will generate a pseudopotential. This is for the s orbital, this is for the p orbital, this is for d, and this is for the f orbital, and these 2 flags are for the core correction. By default, their value must be 0. By default, their value must be 0. And these are basically comments. And below it is basically a scale. These are simply comments. These are comments just for your reference. Means it is the cutoff radii for s orbital, it is the cutoff radii for p orbital, it is for d, and it is for f. And these 2 columns where it was written 0.00 and 0.00, these 2 for the core correction. Means if you want to include the core electron, because in some cases core electrons play a very significant role to determine certain properties. Dr. Vijay is also there. He knows the importance of core electrons. He is from the chemistry side. So we are also taking care of the core electrons also. Because we are approximating the things. We are not including all the electrons. But anyhow, we are trying to incorporate the role of the core electrons. Right? Another very important thing which you have to keep in mind, that it was written PG. When you write down here PG, then it will simply generate pseudopotential. But if in place of this, PG, if you write down PE, that means you are generating a pseudopotential with core correction. That's the meaning of it. If in place of PG, you write down PE, that means now you are generating pseudopotential with core correction. Right?
Sir, एक question है. सर आपने 4, 3 and 4 total number of electrons जो आपने किए हैं, 3 जो है 4 है और 3 जो है वो orbital number of orbits.
Core है, core.
3 जो है number of orbits. 4 is the number of electrons in first case. 4 and valence you have mentioned that.
These are 4 and these are 4 states.
4 states.
Yeah, this is 1, this is 2 and this is 3.
I agree with that.
Yeah.
3 is basically represents the orbital number. So valence orbital number.
Huh.
And 4 is the number of electrons lying in the outermost orbit or valence orbit.
Yeah.
Right? And then 3 is 0, that means s orbital, T1, P orbital, T2, T
It means 3s2.
Sir, वो नीचे जो configuration है, जो आपने right किया.
Okay, this 4.
Yes, yes.
You are talking about
3.
4,
That
3.
means
Okay.
we are discussing about f orbital.
F orbital. Okay. Because F orbital starts with 4.
Yeah, that
Yeah.
start with 4, but here electrons are not moving towards the 4th orbit.
No. They are empty, so that's why we are taking it as 0 and 0.
Yes, I agree with that, but there is no 4s orbit, no 4p orbit.
Oh, you.
Only we are included here 4f orbit.
Okay.
3sp, df there.
Actually, you have to mention all S, P, D and F.
Yes, I want to know why they are missing from this.
It is basically default code was written in this way. Basically, for your calculation, S and P, these are two required, but it will use all the orbital. It will need all the orbitals S, P, D and F. But if electrons are not sitting,
Please explain furthermore. I can't get this.
okay. 1s2, 2s2, 2p2, these are the core states, and 3s2, 3p2, these are the balance states. That is more than enough to generate a pseudopotential. There is no need to take another. But by default, as the code was written, they ensured that when you require a pseudopotential file to be run for the CS star, it will need all the orbitals, S orbital, P orbital, D and F orbital. So if electrons are not sitting in the D and F orbitals, then you make them 0. That's what I do, right? And D orbital starts with n is equal to 3 and F orbital starts with n is equal to 4. If it is not there, you have to start with the 3 and the 4. Not to take 3f is not possible. Quantum mechanically, 3f orbital is not possible, right? That's what I want to say. Is that clear now? Then let me come to the last very important point. So what was that? This is basically the scale. This is very important point. If you don't follow this step, then always there occurs a error and pseudopotential will never be generated. If you missed one column, then pseudopotential will not be generated. Files will be empty and PSF file will be generated, but that is empty. So it's a very important point. So listen, it is, that means this is first column, this is second, third, fourth, fifth, sixth and so on. This is 10th column. If we try to look at it, this is the 10th column. This is 10th column. Next, this is again 10th column. Never forget this. Next 10th means 20th column. This is a very important point. It was mentioned in the manual, but it will take a lot of time to understand it. This is a very important point. This is also 10th column. So ensure this scale should be there always on your systems when you, so better you copy silicon system and rename it and make changes according to your system, and then pseudopotential will be generated. Again, see this. This is also 10th. This is also 10th. So this is a very important point. So with respect to this, TM2 is written this way. Means T is written on 9th column, 10th column and 11th column. R is written on the 11th column. S size should start from here. And this was written on the 5th column. PG is written like this. It was written from here. As TM2 finished, after that you can write down the system name. This is a way to look at the input file. This is a very important point. So everything is fine, clear, any doubt? I think no doubt. Then now I will save it and try to run it. Try to solve the problem which are already have been solved. हमें हमेशा नई प्रॉब्लम नहीं सॉल्व करनी, जो किसी ने सॉल्व की है, किसी ने करके दिया है, उसको भी समझना बड़ी बात है. So let me save it. What is the way? Okay. SH है command. Ashutosh, is it SH now? Yeah. SH double dot slash go inside the utils. Utils था? नहीं. Utils था. Okay. Oh, you come outside. Just a minute. Okay, utils, yeah. So it is PS generation SI underscore test. I have not disturbed the directory which was given by them. I made it different directly. I copied the input file and you can make changes according to your system. So now copy double dot slash, you come outside it, and in the tutorials there is a directory named utils. And in utils there is a script pg.sh and the name of the input file. Let me smaller the size. What is the name of your input file? It is si.inp with space. This is the command which I have given. Is it visible in the last? Yes? Not visible. Not CP but sorry, SH. Command is it's done. So what is the command? sh double dot slash utils pg.sh na.inp. This is the command. Right? So I think it's done. Let us try to look at it. Let me go this way. It is Pseudo, inside pseudo there is this one, and tutorials inside it is this one. Then yeah, this was there. This is the PSF file. It was generated. So let me open in first of all command line. This PSF file or PSML file or BPS, these are the pseudopotential files. So generally I prefer to use PSF file. For PSML support, you have to install CSTA in a different manner so that it can use PSML support pseudopotential. But I will use PSF file, so it is si.psf. Let us try to understand this file, what it indicates. So this is the system name. This is the system name. Silicon atom. Ca means separately, A means elder, Rel means relativistic, MC means listen it, वीडियो अपलोड हो रहा है, लाइव हो जाएगा, आप फिर देख सकते हो. Just trying to understand that what I am saying. NC means no core correction. PSF फाइल अपने आप बोल रही है, गड़बड़ नहीं करनी है. खुद चेंज करोगे अगर मैनुअली, कुछ नहीं होने वाला, कैलकुलेशन गलत हो जाएगी. कुछ करते हैं बच्चे, मैं बोलता हूँ रिलेटिविस्टिक pseudopotential लाओ, REL खुद भी लिख देते, they become very smart. MC, and for core correction it was written as CC. Then it is 3s2. Its cutoff radii will be 1.89, and for 3p its cutoff radii will be 1.89. For 3d it is this one, and for it is this one. So that means all orbitals have been taken care, and this is the data. I am not talking about this data. Now I will discuss with you that what these files are saying to me. So it is simply pseudopotential file which is needed by you during your calculation. Let me do one more thing. So, it contains, after running this, it has created a directory SI. So I am going inside it. This is the directory and it contains so many data. And there are some GNU plot scripts. And if you run those GNU plot scripts, GNU plot is basically a graph plotting tool, and it's a very beautiful tool to visualize the mathematical function. So now I am switching over from here to the GNU plot. I have also made one video on the GNU plot, but that's a very small video, but that may help you a little bit. So first of all, let me talk about the GNU plot. I am just coming outside it. Yeah, GNU plot. How many of you worked in the GNU plot? How many worked in GNU plot? GNU plot is a free graph plotting tool and it's a very beautiful tool. For example, plot sin x. This is the plot of the sine function, and if you want to plot cos with it, then you can plot it also. See, these are the plots of the sine and cos function. And there is a way to make a script of GNU plot. I have mentioned it in my YouTube channel. It's a very small video on the GNU plot. You can go through that. But I am not talking about GNU plot here. I just want to tell you. And here, These are the GNU plot scripts. ls star dot gps. These are the GPS scripts, and there are also gplot scripts. So we have to run these. So what do we do now? This is a very important file, sudo.gplot. So what you will do, GNU plot, then load in single or double quotes. You have to mention the name of the file, gplot. Means I am just trying to look at this. That's it. These are the plots which are there. I will talk about these one by one. You can also use GPS. In GPS it made a file PostScript output in the sudo.ps. So already ps file is not there, but now it's there. It is where is sudo? Yeah, it's there. ps. It's like a PDF file. PDF, but its extension is, but its purpose will be different. You cannot open it in window. For window you require a different software to open a ps file. Means it is a PostScript file. So I go inside it. Let me talk about it. Yeah, this is the sudo.ps file. Now let me okay, it's not open, but rather than this, better if I will use GNU plot, load sudo.gplot. This is for 0, this is 1, this is 2, and this is 3. Let us try to understand this file now first of all. Is it visible to all? Then I couldn't do anything because it cannot be enlarged. So let me explain it. What was written on it? This green colored is the all electron. This is AE wave function with L is equal to 0. This plot, I am just plotting it. This plot, it was like this. So this is the radial plot of S, right? Means it is okay, sorry. And another is PS wave function with L is equal to 0. So this green colored is basically this one, sorry, red colored, जो मैंने अभी ये किया. और दूसरा है, I'm just coming to the next. Another is this one. It was like this. It is the radial plot of this another one. So oscillatory behavior is not there. So it is जो मैंने green color से plot किया, it is basically it corresponds to 3s orbital. Green color. So ये इसका behavior है, but it is all electron wave function. If I try to look at the 3s radial part wave function of 3s orbital, then that should be like this. But what is happening? we are not worried about these oscillations. So what we require a different wave function whose behavior is similar to this all electron wave function, but after certain cutoff radii, so that this oscillatory behavior will not be considered. So that means our cutoff radii will be 1.89 roundabout. So beyond this it will matches, and it is the logarithmic derivative. So it should be matching. I am not going into the detail of it, but if you are getting some ghost state, in that ghost state, because this green colored, it contains sometimes double peaks. It contains double peaks. So that means there are some ghost states, and it is also mentioned in the out file. It is also mentioned in the out file. Then you have to play with the cutoff radii. जो cutoff radii हमने लास्ट में ली थी, लास्ट रो में स्केल से ऊपर, उसको आपने चेंज करना है धीरे धीरे so that it will match. Means all electron wave function must match with the pseudo wave function, and it is the Fourier transform, and this is the wave function. This is the pseudo. Sorry, it's not a wave function, but it is the pseudo potential. Actual potential is the Coulombic potential. Means it should be like this, but our potential is like this, and it goes like this. So this is the potential, but which potential is this? This is the pseudo potential. And what about this? This is the Coulombic potential. Means after certain cutoff, your potential, means pseudo potential, must match with the actual potential. It's the 1/r like shape. That's it. So this is all about this. Similarly, we can look at the other orbitals also. And this information is also contained this is for other orbitals. And this all information say it is all electron wave function for 0, all electron wave function for 1, all electron wave function for 2, all electron wave function for 3. I can plot these separately also. For this, you can use another codes also, but you should be familiar with the data. For example, XM Grace, I will open XM Grace. There is some problem with it. What you should do, if you want to learn pseudopotential generation, you should go through my my YouTube channel. In detail, even I changed the cutoff radii or anything else and then generated different pseudopotentials. You should go through that also for tomorrow, so that if there is any query regarding that, I will try to sort out those things. So now, what I will do, I go to here, import data, and it's not a dat file because its extension will be dat, so I simply put a star. So inside it there is a silicon directory. Say it is the all electron wave function. This is the plot of this actual plot. Let us make it thicker. See, you can change the axis also. Go to the axis properties and try to change. So better if you use it up to the 5. See, this is the wave function. You can plot these wave functions at your own level, but you have to understand in which column what was written. Right? So I think this is a brief introduction to the pseudopotential generation, And let me show you another very important thing. It is the out file. It contains all the information. This out file, inside the silicon directory, there is a out file. Say, here is the full information. What parameters you have chosen. If you have the go state, it was written in the out file. And these are the eigenvalues of energy, potential energy. And this corresponds to all electron. Eigenvalues of energy, difference between this and for this, not for this, but for pseudo, it should be, because 3s and 3p, let me, this corresponds to this, these eigenvalues corresponds to 3s and 3p. I'm just taking its screenshot, and let me go to here again. It is 3s and 3p, right? I have to compare these only. If the difference is up to the 4th or the 5th decimal place, that means your all electron wave function is matching with the pseudo wave function. But if the difference is not is significantly large, then your pseudo potential is not good. Then what you have to do? You have to play with the logarithmic cutoff radii or cutoff radii for the different orbitals. You have to play with that and nothing else. Let me go to the pictures, and I have taken a screenshot. Yeah, it's in the screenshot probably. No, yeah, it was there. Just see the difference. They are almost matching. They are almost matching. So one thing, to test your pseudo potential, you have to compare the eigenvalues of the energy of the all electron and the pseudo, and another thing, your wave function must match. Third testing of pseudo potential is that what you have to do, you have to reproduce some result. Lattice constant, binding energy, band structure. But DFT codes, especially siesta or LD or GGA, energy band gap is underestimated. This is the drawback of it. For that, we have to move towards the hybrid functional. But hybrid functional is not with this code, with the free version. Soon, I am expecting soon they will give you the access of the hybrid functional, then things will be much more better. Right? And this is the last thing which I want to mention with, share with you. I am just coming outside. Now I will do the core correction. I removed this directory. Which directory? Which created due to the run of the atom code. Using the script, right? I have to remove it. So remove dash R, SI. Oh, sorry. Dash R. Yeah, it's removed now. Now I again run the script, but with some slight modification. si.int, you give a command PE. Rather than PG, now I am using PE. Let us see whether core correction will be there or not. So pg.sh, sorry, not pg.sh, but it is, because input file is already there, I am making change in the same directory. So sh //utils pg.sh si.int command with. Now here PG remains the same, but PG changes inside the input. In place of PG, you have to write down PE. See, output data in the directory, this one, CD. Okay. Let me see this first of all file, that si.psf. This is the core correction PCEC. ये अपने आप आ गया, रन किया. जब आपने PE लिखा अंदर इनपुट फाइल में तो उसने ऑटोमेटिकली कोर करेक्शन करके दे दी. It was also written in the now this what we call out file also. So vi out pseudocore inside this. So this is a way that how a pseudopotential will be generated. Now, as a homework, what you will do, you can generate pseudopotential for others like sodium, potassium, copper, silver, and your own pseudopotential should be there, and they should be tested in this way. This is a preliminary testing of a pseudopotential, and another final testing will be that you will do one thing, that you have to reproduce certain results, right? So I think that's all for this session on my side, and now I will answer your questions after finishing this, right? I will answer.